Hello everyone. Today we will be learning about writing proofs. So last time you did the UNO proofs and we saw really the format of the proofs. So we started with a given card and we wanted to show logical steps to get to an ending card. And with each step we had to say why we were able to make that step. So for instance, if I had a green 4 and I placed a green 7, I can say I can place that green 7 because they had the same color, and so on. And so really writing proofs in geometry is going to be the same format as that. We have a given information and we want to show logical steps to get to something that we're trying to prove. So we're going to be following that same format. And so steps to writing a 2-column proof to remember to kind of help you get through, because this is a harder topic, is to first copy all given information. So your first step, you're going to copy all the information that's given to you on that left-hand column for your statements. And then always your reason is that it's just a given. Your second step is to pause to get an understanding of what you know and what you're trying to prove. Here's a good step to make marks on your diagram. So for instance, if you're given that AB is equal to CD, you'll want to go in that diagram and actually mark those tick marks to show that those segments are equal to one another. Next, you're going to write and work with equations based on the given statement if possible. Sometimes you can convert statements into equations using definitions. So an example of this would be, let's say that you're given that angle 1 and angle 2 are complementary. From that given equation, that given statement, you can then convert that into an equation by saying that measure of angle 1 plus measure of angle 2 is equal to 90. And your reasoning for that would be definition of complementary. So that's an example of when we can convert our given statement into an equation. And then step 4, we'll develop new equations from the diagram if possible. So an example of this is if we had, like we saw earlier, a diagram here, and let's say that AB was equal to 2x, BC is equal to 5x, and AC is equal to 10. You can create an equation from that by saying, okay, well that means that 2x plus 5x is equal to 10 by the segment addition postulate. So that's an example of when we can create an equation from the diagram. Another one would be if that B was actually in the midpoint. You can create an equation from that as well. And then lastly, manipulate and combine your equations, always keeping your goal in mind. And you can sometimes use the transitive property in substitution to combine two lines. So an example of that would be, let's say we had that measure of angle 1 is equal to measure of angle 3. And we also had the measure of angle 1 plus measure of angle 2 is equal to 90. Well, then using substitution, I can then replace the measure of angle 1 with measure of angle 3 to say that therefore measure of angle 3 plus measure of angle 2 is equal to 90. So we want to keep all this in mind when we're going through proofs of different ways that we can manipulate it to get to the end that we want. And something to just recall, for any segment angle, we have that reflexive properties. That is when we just state that something is congruent to itself or equal. We have the symmetric properties, so that was if AB is congruent to CD, then CD is congruent to AB. And then a big one that we'll use a lot is the transitive property. And so that one you're going to be combining two different lines. So here I had, let's say I was first given that AB is congruent to CD. I know that CD is congruent to EF. Well, since AB and EF are both congruent to the same thing, that means that they are therefore congruent to each other. So let's go through an example of going through a proof. So here I'm given that B is the midpoint of AC and C is the midpoint of BD. So my first step is I want to copy all of the given information first. So I'm going to copy that B is the midpoint of AC. And again, that's given to me. And then C is the midpoint of BD. And then since I know I'm trying to prove AB is equal to CD, I know that's going to be my last step, so I'm going to go ahead and copy that down at the bottom here. And so now I need to fill in these 3 other lines. I need to somehow get from these 2 statements to that AB is equal to CD. So now I need to look at, what do I know about midpoint? What is that definition? Well, if B is the midpoint of AC, I know that AB is congruent to BC. So I can write that as my next step. And you notice I put tick marks in my diagram here. And so I can write that. This means that AB is congruent to BC. And what did I use there? Well, I used the definition of midpoint. And now I can make that same statement with C, or that C is the midpoint BD. Since C is the midpoint of BD, that means that BC is congruent to CD. And again, that's definition of midpoint. Okay, now I need to figure out this last step. How do I get from these 2 things to that AB is equal to CD? Well, I noticed that in these 2 steps here, AB is congruent to BC, and BC is also congruent to CD. That's the same thing here. So that means that AB is then congruent to CD. And what's that reasoning again? Well, that's my transitive property. Which we saw that up here. And now I was able to go that since AB is congruent to CD, that means that they're equal to each other. And remember, that is my definition of congruence.